Today we are going to discuss lecture number 49. 49, which is the phasor diagram of synchronous motor. Phasor diagram of synchronous motor. Okay. So the phasor diagram, this topic is already explained. Okay, in the lecture number 39. Okay, lecture number 39. But anyway, I'm going to just recollect the topic. The phasor diagram of synchronous motor is almost similar to that of synchronous generator. That is nothing but alternator. Here, the effect of armature reaction can be substituted by a synchronous reactance or equivalent resistance reactance value XA and synchronous reactance XS. We have to include it. So how to include these two values in our what is that, in the phasor diagram or vector diagram, we can say. So you know the general equivalent circuit diagram. Okay, general equivalent circuit diagram of synchronous machine. The equivalent circuit, it will be like this. RA XL, then XS, then here E will be available. Okay, so here plus minus, here there will be AC voltage and current flows, and here there will be a winding. Since it will be a field winding means the rheostat will be there. This is a variable rheostat to adjust the DC excitation plus minus DC. This is AC. So this is stator side. This side will be a rotor side. Okay, this is a equivalent circuit. Now by using this equivalent circuit, I'm going to draw a phasor diagram in terms of power factor. Okay, now please listen carefully. The first diagram, when power factor, that is phi, is positive. Phi is positive. Phi is positive means, sorry, phi is negative. Phi is negative. The meaning of negative, it will be lacking power factor. So how to draw this phasor diagram? First step, this is 0 V. Okay, V point, and the current will be lagging. This is I. Okay, so the angle between V to I will be phi. Understand? The phi is the, phi means, what is phi? Phi is the angle between voltage and current, between the voltage and current. Okay, now Here there will be a drops in the winding arrangement. Okay, here one drop will be there, that is voltage drop across the resistance. There will be a voltage drop across the reactance. So for every passive elements there will be a voltage. A voltage drop means the voltage which we are going to measure across the resistance. So that voltage drop, how to draw? From 0, the line it's coming here, this point, it's nothing but I into RA. Okay, this is voltage across resistance drop. Okay, voltage across resistance drop. So in lagging power factor, this is my center point. Okay, so from 0 to the center, which will be I Z S. This line will be I Z S, and I'm going to join this IA RA to this VA. IA RA to VA. Okay, and this is IA into RA. So the line from the center point to this V is nothing but I into XS. I into XS. So this is IZS, this is IRE, this is IXS. Okay, so this is nothing but phasor diagram of when power factor is negative, which will be lagging power factor. Okay, so the other point, the another diagram, the another diagram is the phi is the phi value will be positive. Another diagram is phi is positive. When phi is positive, it will be called leading power factor. V, the current value will be leading, right? This is leading. Okay, leading power factor. The angle between this phi A, sorry, the angle between IA to ZS will be theta here. Okay, the angle between I to V, it is phi, which is phi. And here the drop across the resistance current will be, this is I into RA, I into RA. So from this line it will be going like this. Okay, and join this line, and I can join this line. This line will be I into ZS, and this line will be I into XS. This line will be I into RA. Okay, so this is nothing but leading power factor. The third diagram will be when phi equal to 0. Phi equal to 0 means cos 0 equal to 1. It is a unity power factor. Within your bracket you can mention, it will be, this topic I already explained, but anyway I am just recollecting these topics. V, the point will be I into RA. The current is also being line in the same line. Okay, so from I into RA you have to draw a straight line. Okay, and join this origin. This line will be I into ZS. This line will be I into XS. Okay, this is the different types of phasor diagram of our in synchronous motor. One in terms of lagging, another one in terms of leading, another one in terms of theta. The angle between this voltage drop to impedance will be theta. Okay, it is theta. Any doubts? Any doubts? So when lagging power factor, it will be called under excitation. It will be leading. It will be over excitation concept. Okay. In terms of unity, it will be a critical excitation will be taken place. Any doubts? In terms of torque, can anyone tell me how many torques are available? What are the different types of torques are available in this synchronous motor? Can anyone tell me? Different torques. Lecture number 40. Yes. Different torques are available in synchronous motor. The first torque will be a starting torque. The torque measured during the starting purpose. That is nothing but starting torque. The second one will be running torque. The torque developed by a motor under running condition. That is known as running torque. Third one will be pull in torque. Fourth one pull out torque. Pull in torque means the ability of the motor to pull into synchronism when changing from induction to synchronous operation. That is known as pull in torque. Pull in torque means the ability of the motor to pull into synchronism when changing from synchronous motor to induction motor operation. Sorry, when changing from induction motor operation to synchronous motor operation. Induction motor operation means is having a two speeds. One is synchronous speed, rotor speed. Since the induction motor will be a variable speed, but you need a constant speed machine. So for that purpose, we are making the rotor speed to synchronous speed. Then we are converting into synchronous motor operation. That is known as pull-in torque. Pull-out torque means the ability of the motor to remain into the synchronism under a rated load condition. Okay, pull-in torque means you take down the ability of the motor to pull into synchronism. Synchronism means the rotor speed and your synchronous speed both are same. Okay, the machine is running at constant speed, no variation in rotor speed. That is known as synchronism. Okay, when changing from induction motor operation to synchronous motor operation. Okay, induction motor operation to synchronous motor operation. This is known as pull-in torque. Okay, pull-out torque means the ability of the motor to remain in synchronism under rated load conditions. Under rated load conditions. This is known as pull out torque. Okay, this is known as pull out torque. Any doubts? These topics it's already explained in a lecture number 40. Okay, and just recollecting the topics, just a revision. Okay, I'm not doing taking any extra topics apart from your syllabus. Okay, I'm just revising the topics. Any doubts, students? The braking mechanisms you know very well. Okay, the synchronous motor may be stopped by either plugging or rheostatic braking. Okay, you have to apply plugging means a dynamic braking we have to apply. That is the concept of braking mechanism. Any doubts? Any doubts?